we just understood the idea of self-inductance. Inductance is metal changing magnetic field. Is a current induced. Now, a wire, we have current flowing through it, produces magnetic field. If there is changing current, it will in turn induce current in itself, an opposing current, right? So this is all the things that we have learned. How effectively this back EMF opposes the existing change. Whatever happening change, whatever happens at that moment of time, how much does it oppose? How effective is it in opposing the change? To give it a mathematical dimension, we have a term called as coefficient of self-induction. So coefficient of self-induction of a coil is the measure of how effectively it, as in the wire, induces a EMF in itself due to the change in current. Okay guys, so let's look at the mathematical aspect. It's quite simple actually. See, any flux is related to current, right? That's the whole idea. Because current produces magnetic field and so on and so forth, any magnetic flux is related to current. So can I write this as some constant L times I? And this constant turns out to be your coefficient of self-inductance. Now let's relate the coefficient of self-inductance and the EMF. So we know from Faraday's law that all of this put together is minus d phi by dt. So when we substitute, L is constant. So this is L minus L di by dt. That is known. So we need to relate, we have already related, sorry, we need to define L in terms of your EMF. So let's do that. So we understand that your EMF is minus L di by dt. Now, how do we define L with this? So this is something that we need to know. This is something we can control. Di by dt is something that we can control. So let's control that. So for di by dt equal to 1, what happens to the entire expression or equation? It would turn out to be this. And now can we define this? Yeah, we can define it. The self-inductance of a coil is numerically equal to EMF induced in the coil when a current through the coil changes at a rate of 1 ampere per second. So this is nothing but your rate of change of current. Change of current. So when the rate of change of current is 1, numerically these two will be equal. And that's how we can define self-inductance. SI unit and everything. We'll be looking at it in the next video. For now, just an introduction and definition.